Today is ultimately kind of special for me in particular. So there's very few decisions, I think, in life, to be honest, that really influence your path. For instance, choosing which college you go to certainly influences pretty much the rest of your friends that you'll have for several years after that. And frankly, even just taking one or more courses or picking your concentration really does leave an indelible mark on your future. And so not to sound too grand here, but as I've said, I did not take CS50 freshman year. I was rather scared off by the course. But I finally got up the nerve to put my foot in the water sophomore fall in 1996. And it was that year that a man named Brian Kernighan was actually visiting us for the year to fill in and teaching CS50. And this was a man who at the time had a fairly long beard, as I recall, because whereas we just have a sock example to talk about algorithms, he had a shaving example, which involved hedge clippers of some sort. So it was correctness was all the more important then. But you remember things like this. And what I also remember about CS50 in 1996 is Professor Kernighan had a habit of having one of the teaching fellows running around the audience. Anytime a student would ask a question, he or she would be rewarded with a little bite-sized Snickers or the like. And I swear to God, the only time I ever asked a question, I think, in CS50's lecture, Science Center B, was because I was hungry one day. You remember these things too. And it was absolutely this course that completely influenced my path in life. And so I'm greatly thrilled that our guest lecturer today is Professor Brian Kernighan.
Okay. Let's see if we're on the air here. We're off the air? We're on the air. Okay. Looks good. Down. Yes. Okay. Anyway, thanks for that kind introduction, David. Yeah, I was here in the fall of '96. The course at that time, a number burned into my brain. Had 457 people signed up at the first of it. It was over in Science Center B. It was more people than I'd ever seen in a room at one time in my life, I think. And it was an amazing experience. It really was. Now, as you can imagine, with 450-odd people in the class, I never met David. I didn't encounter him, in fact, until a couple of years ago, which was, among other things, the genesis of the shirt that I'm wearing so proudly at this point. However, in many ways, I'm quite a compulsive and weird person, and so I still have the grades from CS50 that I taught that time in '96. And if anybody wants to make me an offer, I will reveal David's grades and his rank in the class. If David wants to make me a counteroffer, we can go for that. Okay. Anyway, at the time that I taught the course, I was actually working at Bell Labs in New Jersey, sort of in smokestack research industry. And then a few years later, I went to Princeton. And one of the things that I've been doing at Princeton for, ever since I got there, 11 years at this point, is teaching a course every fall, which is called Computers in Our World. And it's a course that's sort of loosely analogous to the thing that used to be called BITS here, except that it's more hardware and software than that course. One of the reasons that people take it, I think the primary reason that people take it is not that I am a great, wonderful person, which of course I am, but they're taking it because it satisfies Princeton's quantitative reasoning requirement. So it's a check off the box course. And so that's the reason that I've got people in it. There's an official university definition of what quantitative reasoning is. I don't know what that definition is. My definition of quantitative reasoning, at least for the purpose of the course, is doing grade school arithmetic in the service of day-to-day life. So that's what I'm going to do for you guys today. I'm going to give you a quick version of the quantitative reasoning part of that course. It's basically about how to defend yourself against the numbers that lots and lots of other people will give you all the time. If you think about how many numbers you see in everyday life. And it's partly about how do you make up numbers of your own when you actually need them and you'd like them to be sort of okay. Now, what you'll discover as I blather on here is that this is not rocket science. In fact, it's going to be unbelievably trivial and obvious. And so that means that nobody in CS50 doesn't already know this stuff. But you guys are the cream of the cream, right? So you've got lots of friends who don't know anything. Turn off the camera a second. And so maybe you can pass on some of the messages to them. Okay, so that's the hope. Alrighty. So let's see. See if we can make this work. Yeah, okay. So here's a story that showed up in Newsweek magazine about 6 years ago, I think. This was at a time when gas prices were rising rapidly, although in fact, at that point, they were substantially lower than they are today. They were well under $2 a gallon, but people were whining about this. And one of the suggestions made was that the Strategic Petroleum Reserve be tapped. Economics. Don't they teach economics here? Sure, they teach economics here. They even have successful economists like, no names, in Washington. Yes, the suggestion was that if you improve the supply of oil, therefore gas, then the prices would fall, and this would be to everybody's benefit. And so it says here we got 660 billion barrels, and we could use that to reduce the price. And there's one other useful fact in the article. It said that the average vehicle goes 550 gallons a year. So the question that comes to mind is, suppose you do this. How long is this reserve going to last? Okay, so let's work on that. To do that, you actually need to do two things. You have to figure out how many vehicles are there, okay? And the other thing that you have to figure out is how big is a barrel, because this was denominated in barrels. So let's talk about those two things, okay? How many vehicles are there? Well, think about it. If you live in Cambridge, you've got no place to put a car, so you probably don't mostly have one. But lots of other parts of the country, almost everybody has a car or two or three. So if you kind of made a guess that said everybody's got a car, you'd get roughly a car per person, and so call it 300 million. Could be wrong, I don't know, but it's probably not wrong by a factor of more than, I don't know, factor of 2 or something like that. So that's okay. If you've ever driven through any part of Cambridge or Boston in the rush hour, most of those 300 million are right there in front of you. I learned that as a tourist. The other question is, how big is a barrel? So you've probably seen, if you go around old construction sites and so on, you've seen 55-gallon drums. So that's one possibility of what a barrel is. And there's another dimension. I'm guessing nobody here has ever actually seen a beer keg. So, but somewhere in this range between a beer keg and a 55-gallon drum is probably a barrel. Okay, fine. So let's call it 50 gallons on the grounds that we don't actually know. Let's just see what happens. So now we can start to do quantitative reasoning. I'm going to simplify the numbers. This is always a good deal when you're doing quantitative stuff. Simplify the numbers as much as you can. 550 barrels a year, it doesn't matter, for 550 gallons. Make it 500, that's easier, so that's 10 barrels a year at our assumed 50 gallons in a barrel. 300 million cars, 10 barrels a car, that's 3 billion barrels a year. Okay, no problem. The reserve has 660 billion barrels. Okay, we're using 3 a year. The thing is going to last 200 years. What? Why are we so worried about oil? That reserve is going to last until everybody in this room is dead for a century. What's the fuss? Why don't we just tell all those folks who make trouble in other parts of the world, go away, we don't need your oil, we got our own. So this is the place where usually somebody in a smaller audience than this says, well, but you didn't allow for buses and trucks. You forgot about the population growth. Most people have 2 cars, whatever. All of those could be true, but they don't make much of any difference. What's the real answer? Well, Newsweek actually revealed it. They said, we screwed up. We meant million, and we said billion. Okay. So what's a factor of 1,000 among friends? Meh. And of course, if you do the arithmetic with this number, then the Strategic Petroleum Reserve would last for a couple of months, and then it would be all gone. And that's the why we still worry about oil. There's probably one other thing that you might be wondering, and I certainly was when I first encountered this story, but then a little bit of research discovered the answer. One of my favorite news sources, the New York Times, says that a barrel is, a correction, 42 gallons, not 42,000 gallons. So you can imagine a variety of ways in which you could either come up with the right answer or a seriously even worse wrong answer than this. Okay. So this confusion of millions and billions and other big numbers is endemic. Here's just 4 random ones that I picked out of the papers over the last little bit. Billion, not million, for bailouts, for the budget deficit, for credit limits, ailing European economies in euros instead of dollars. Lots and lots of these things. What's going on here? The trouble is, I think, I mean, maybe you guys are different, but I think for most people, we have no intuitive grasp of what a million is. Okay, it's like this big? No, maybe it's this big. Okay, and then what's a billion? It's bigger. And a trillion, that's a lot bigger. Okay, so it's big, really, really big. And that's the quantitative value of those words. And so people can't spot things like this because they don't know how to actually deal with them. How do you cut big numbers down to size? One suggestion that actually works in a lot of cases, though not all, is to say, how does it affect me personally? And you'll see this in the paper a fair amount as a way to deal with it. So for example, this showed up, there was an article about how Obama wasn't selling things properly in his going around the country to try and get Democrats rescued in the election of last week or whatever. And it said that the budget deficit stands at $1.3 billion. New York Times, okay? Arguably the best paper in the country. Is that number right? Well, I don't know. How much is that per person? And that's a useful way to do it. Well, we already discussed there's sort of 300 million people in the country, so the deficit is about $4 a person, okay? So here's a plan for deficit reduction. Tomorrow, everybody in the country forgoes Starbucks and instead sends $4 to Washington, right? Deficit's gone, 1 day. No pain or grief for anybody. We just did without coffee for 1 day. Okay, so that would be one solution for this problem. Another solution is you could take some recent Harvard dropout and get him to pay for it single-handedly. You know, that would work too. Well, here we go again. The deficit is actually trillions, somewhat over $1 trillion, and therefore the actual number is 4,000 a person. And that's more likely something that's going to hurt you in your wallet. I'm darned if I'm going to send $4,000 to Washington if I don't have to, okay? And so the reasoning that goes from here's the number, how does it affect me personally, down to what would that imply is, I think, quite a useful one. Okay, so this is dollars, or euros. We're all familiar with money. What happens when you start instead to get into something which is less familiar, except to you guys, okay? Think about computing. There's an enormous number of words that we use to talk about how big things are in computing, you know, like mega and giga and all those folks. For the proverbial man or woman on the street, those are much less familiar. What do you do about that? So what you do is you write stories about them, and then you make corrections, okay? And so the New York Times says, a petaflop is 1,000 trillion instructions per second, not a million trillion, right? So we don't understand the big words, but let's compound them into things like million, and then teravolt, or tera electron volts more accurately, is a million, not a billion. Okay, the mind in some sense can't cope with all of this stuff. Scientific notation would be a better way to deal with this, right? Where you would say, look, a million is 10 to the 6th, a billion, giga, is 10 to the 9th, a trillion, tera, is 10 to the 12th, all those kinds of things. You're familiar with that. That works, but lots and lots of people kind of tuned out in elementary school before they got to that point, or they've forgotten it since. So that's not a good solution. This shows up in some funny ways. These are, I mean, everybody here has seen these units. You can't avoid them, right, in a computer course period, for sure. And you see them in the paper all the time as well. It gets less familiar afterwards. There was a story just before Christmas, people, you know, thinking about buying ebook readers for family members or friends or whatever. And there were two stories back to back almost in the Wall Street Journal and the New York Times. The Wall Street Journal was talking about the Nook ebook reader, an oddly titled or named device, and it says it has 2 gigabytes of memory, enough to hold 1,500 digital books. Okay. The other story in the Times a day later said that a zettabyte, which is 10 to the 21 bytes, or 10 to the 21 bytes, I don't think the Times said it that way, is equivalent to 100 billion copies of all of the books in the Library of Congress. So it's an astonishingly big number. So at that time, David, take a note. At that time, I was preparing the final exam for my class at Princeton. And I thought, this is a gift from God. I can make a dynamite exam question from this. Okay, and here's the question. How many books are there in the Library of Congress? Because from this, you've got enough that you can estimate. You know how many bytes are in a book and how many bytes there are in 100 billion copies of all of the books. You should be able to do the arithmetic and come up with the answer. Golden opportunity. So how many books are there in the Library of Congress? Let's compute it. So the Wall Street Journal says it's 2 gigabytes in a Nook, 1.5 times 10 cubed bytes in books. Sorry, that should say books. So therefore, it's 10 to the 6 bytes per book. It's roughly a megabyte a book. No problem. The New York Times, 10 to the 21 in 100 billion. So that says it's 10 to the 10th in one copy of all of the books in the Library of Congress. And doing the division, the number of books in the Library of Congress is 10 to the 4th. Okay, everybody with me so far? So the question actually had 2 parts. The first part was, do this arithmetic correctly. Turn off the camera for a second. I don't want to discuss Princeton, but it was not as well handled as I might have liked to have seen. It would have been better here. Or maybe not. You can never tell. Anyway, the second half of the question was, okay, you've got your answer. Is that a reasonable answer? Is it sort of way too big, way too small, or maybe probably about right? We know the Library of Congress has 10,000 books. It was stunning. How many people thought that that was a plausible estimate? So I was curious. I actually went and looked. In 1638, some dude named John Harvard, who has this bright toe over there, where donated 400 books to establish this place. It's probably grown since then. The Library of Congress is much bigger than the Harvard libraries. 10,000 is not a plausible number, but people didn't seem to think of it that way. Okay, so the problem, and I'm sort of beating this to death in a way, the problem is it's sort of we're buried in numbers that you can't pick up a newspaper or a magazine, you can't turn on the TV or YouTube or whatever and watch a story about anything without counting numbers. At the same time, we rely on computers to do our numbers for us. We kind of don't do numbers with pencil and paper anymore or anything like that. And so as a result, we're losing our ability to do arithmetic. We're losing our ability to assess numbers that other people give us. We're losing our ability to create our own numbers by computation or just by assessment. So I've given you a bunch of examples of this. I'll give you some more. But then I'm going to try and start also to talk about things that you might do proactively to make things work out a little better. Okay? So one of the most useful things you can do, and you can see it here, is to say, here's a number. Is this number likely to be way too big, way too small, or maybe kind of in the middle somewhere? Sort of a form of what you might call, if you were in medicine, triage, numeric triage. Way too big, way too small, somewhere in the middle. Okay, so this is the thing you might want to ask. So I'm going to ask you this for a couple of questions, and even though I can't see a damn thing, I would like you to raise your hands without anguishing about what your buddies are going to do, anything like that. You know, just spontaneously, when I give you the question, I will then ask for these 3 categories. So here's the question. This is an oldie but goodie. Americans receive almost 2 million tons of junk mail daily. This is Dear Abby from a long time ago. How many people would say this is much too high? Sort of a third. How many people would say it's much too low? Rather more. Maybe the same. And therefore, how many people would say it was about right? Sort of, you know, broad range. And then how many people didn't care to express an opinion? Okay. Chicken. All right. So you can make this guess, it's your gut reaction and so on, but you can actually do better than a gut reaction. You can actually estimate this, and let's do that to see what happens. 2 million tons rather, is 4 billion pounds, 300 million Americans, and therefore that's about 13 pounds a day of junk mail. Now, when you get back to your dorm or whatever, how much junk mail do you expect to see? Have you ever seen a mailman or a mailwoman walking along with this thing under their arm or maybe pushing a little cart? Have you ever received mail at your home? 13 pounds is preposterously too high, right? It can't possibly be right. And we got that by sort of saying, look around and observe what would be the consequences if it were true. So what went wrong here? I think what went wrong probably is a confusion of units. This is daily, but I'll bet it was yearly. I'll bet. Because if you take this number and you divide it by 365, you can normalize it by number of people in the family and all this kind of stuff, you come out with something that might be an ounce or two a day for a family, and that's much more plausible. So I'm guessing that that's what it is, but I don't actually know. Okay? Here's another one. Quickly, much too high, 60 tons a year of food. Not too many. Too low, substantially more, about right. A bunch of people are afraid to commit themselves, even more than the last time. This is bad news. David, you've got to whip these people into shape. Class participation scores will be low this year. You can reason about it. Let's reason about it in a way. One of the tricks of reasoning is to simplify radically, on the theory that if you simplify too much in one direction, in one piece of it, you might compensate by simplification that goes in the other direction somewhere else. So here's the way I would do it. I'd say 60 tons in a lifetime. How long do you live? Exactly 60 years. Okay, I'm dead. So you live, you die. But, well, isn't what they teach you in philosophy course? Anyway, if you do that arithmetic, then that says 1 ton a year, okay? Now, that's obviously not quite right, because when you're a little tiny kid, you don't eat that much. When you're much older, you don't eat that much. And in between, sort of roughly your age, you probably eat a lot, okay, comparatively speaking. But doing the arithmetic roughly, that's 2,000 pounds a year divided by 400 days in a year, roughly, that's about 5 pounds a day. This is not too bad an estimate, right? People on the average will live a little longer than that, et cetera. But it's within shooting distance. So this is one of those, yeah, this is a plausible kind of number. Okay? One more while we've got it here. Do I have to do the survey? So this is a place where sort of backwards reasoning is actually very effective. If it cost $88 a day to run your computer, how many people would have computers? You know, I see those little glowing apples all over the room. You wouldn't be able to afford it. Or the other way to look at it is that instead of, you know, powering it off every, you know, you throw it away after 10 days and buy a new one, right? Because it would be cheaper, because it would have a new battery in it. So this is clearly nonsensical. How do you get to that? Well, there's a bunch of let there be a little bit of comic relief. Sorry about that. Anyway, maybe I should pace in the other direction. It's just that I'm naturally a leftward pacer. Anyway, does the number make sense? You know, somebody gives you a number. You think, does this make sense? Could it possibly rewrite? Well, how would it affect what I see every day? I don't see a mailman carrying 13 pounds of junk to my house every day. Something's wrong. And then the backwards reasoning made it a little more formal. If this number were correct, what would be the implications? If it was 13 pounds of mail to my house every day, the post office would be the biggest employer in the country, or something else would have changed. If it were $88 a day for power for a computer, none of us would have computers in our homes, right? So clearly cannot possibly be right. How about this? NASA experimenting with high-speed stuff. I think it was aimed at missiles rather than at passenger flying, but here's an example of a consequence kind of question. How many people here live on the West Coast, roughly? Yeah, fair number, okay. You know how long it takes to fly back to Los Angeles or, you know, Seattle or something like that. Can you imagine you get on a plane at Logan or something like that, plane takes off and the pilot says, please fasten your seatbelts, we'll be landing in Los Angeles in 30 seconds. Doesn't work that way. Would that it did, but it does not work that way. So this number cannot possibly be right. I think down here the 7,000 miles an hour was probably the correct part. I should go back and do the arithmetic. How about this? People here in the crew? There's a few people on crew. This is really white water. The head of the Charles, man, this would be something. For those of you who are not from northern New Jersey, the Passaic is actually very much like the Charles. It's a fairly wide, fairly placid river that flows essentially flat like that. There is actually one major difference. I believe that if you accidentally fell into the Charles, you'd live. Anyway, this is clearly nonsensical. 200 miles an hour is really, I mean, that's the takeoff speed for the plane that's going to take you back to California or something like that. So this can't possibly be right. I took this picture myself from the railway bridge that goes from New York down towards Princeton, passing through Newark, where the newspaper that wrote this article is published, and presumably whoever wrote the article could look out the window and say, I don't think it's 200 miles an hour. Anyway, I think what happened here, and it's another one of these things that you see, it's units. Probably it's per day. I am told by people who do stuff on rivers, outdoorsy people, that rivers are often measured in miles per day. And so 200 miles a day would be about, oh, call it 8 miles an hour. That's not too bad, as 5 times the normal for something like this, maybe a mile or 2 an hour. And that's sort of what you would see if you go and look at the Charles as well. So that's probably what happened, although I don't know. Okay, so it's helpful if you know some stuff so that you can get around this to have some notion of how fast things are, or how big they are, or how much they weigh, or how you convert from one to another. This is one of my lists of facts that I sort of keep in my head, or usually in my head. And you should have some of your own, because the more of them you got, the more likely it is you could do a decent job on reasoning about something, okay? One of the reasons you want to be able to do that is, I am told, I have a job, so I don't have to worry about this, but I'm told that people who want to get jobs sometimes have to go through interviews. And is this correct? Maybe not at Harvard. And old family connections or something. And if you have an interview, sometimes, depending on the field, that you might be asked a question where you have to estimate something or other. Has this happened to anybody here where they say, how many of this, or how much would this take, or how long would it? Has it ever happened to anybody here? Yeah. It happens to folks at Princeton too, often for the same kinds of things. They're going to be thinking iBanking or something like that. So it's very useful to have facts in your head and some notion of how to put those together arithmetically so that you can do estimates. Here's an example of something which is purportedly an interview question from Google. Now, I've talked to friends at Google and they say, well, I don't think so. Certainly not for a programming job, which is presumably what some of you would like, but anyway, the question is, okay, there's a school bus. How many golf balls can you put in it? Okay, so this is, I just threw some money on the floor. Next, no candy, we've moved up. Anyway, what the heck was I going to say? I can't even remember. So this is an example of the kind of estimation question you might be prepared for. And what you don't want in an interview kind of setting is to look like a deer in the headlights, okay? What you'd like to say is, oh, well, here's how I would approach it. How would I approach it? I would say, here's a golf ball. It's a cube, 1 inch on a side. It's not round. Golf balls aren't round. They're cubes, 1 inch on a side. So that means that 12 by 12 by 12 is, you know, what, 1,700, 2,000-ish golf balls in a cubic foot. How big's a bus? Well, let's call it 8 by 8 by 30 or something like that. That's my number. 5, 6, 7 million, something like that. That's the way I would do it. And if you do that kind of thing in an interview, somebody will be utterly blown away because, oh yeah, sure, that's quite a plausible way to do it. Much better than the deer in the headlights. So, David, take another note. The question I have asked from time to time in my class is, here's a disk. You've seen these things, right? This is a disk. This is the inside of the disk. This is a disk out of a laptop. I would take it out of the one I'm using, but it still works. I would take it out of David's, but his probably still works too. Anyway, you get the idea. So suppose you filled Sanders Theater with these things. How many petabytes? It's another one of these questions of, you know, how big is a petabyte? Well, this tells you something. You have to know how big these things are. And in my class, I encourage people to attend. I realize most people don't attend here, but then they've seen one of these, they've even fondled it in their hot little hands, and so they've got a notion of how big it is. They know, because we talk about what's in a computer, they know roughly how many gigabytes or what that might contain. They know how to convert gigabytes to petabytes. And if they've come to class, they even know how big the room is. And so they should be able to do all of the arithmetic. And so that's a good example of my flavor of the can you do an estimate with this thin veneer of technology around it. But it's really the same question. Okay? Alrighty. Another kind of question. Here's a milestone kind of question. I don't read Gambling Magazine. In fact, I've never seen it. I've forgotten where I came across this. But it says every day 10,000 Americans turn 50 years old. Okay, so is that a plausible number? Hey, show of hands again. Let's just get it. How How many people think that that number is way too high? Modest number. How many people think it's way too low? How many people think it's plausibly about right? They haven't learned participation yet. Got to work on this. OK, there is actually a way that you can reason about these things so you don't have to make a guess, an uninformed guess. Let me show you the way to reason about it. It's something that's called Little's Law. And it's called Little's Law because there was some guy named Little who first stated it, although it's kind of obvious. Little's Law is a conservation law. It basically says what goes in comes out. And the way that you can remember it for the rest of your lives, you will never forget it, I guarantee, is think about Harvard, okay? There are about, what, 6,600 undergrads? I don't know what the exact number is, but call it that, okay? So the relationship is between the number of people in process. You guys are in process, okay? You probably didn't think of it that way, but that's what you are. What's the process? You're being converted into alumni donors. So each of you spends 4 years here, so that is the service time. And that means that you can compute either the arrival rate or the departure rate, right? The arrival rate or the departure rate is 6,600 divided by 4, or 1,650. And that's roughly the size of the incoming class, roughly the size of the outgoing class, right? And obviously, this is an approximation. Some people don't finish. Some people take a little longer than that. It varies from year to year a little bit and so on. But this is a pretty good way of estimating what's going on in one of these steady state sort of processes. And it gives you a way to reason about things like every day, 50,000 or 10,000 or whatever it was, Americans turned 50. So let's look at that. Here's another one. Everybody in the country is in process. Everybody who's alive is in process, actually. Let's just focus on people in this country. So there are 300 million people. Suppose you're born, you live, life has been extended to 100, and you die. Okay? So if that's the case, the service time is 100 years, and that means that every year, 3 million people will die. Now, life isn't that good for most people, and so 100 is too optimistic, but maybe 75 is plausible. It makes the numbers simple, and so that means that 4 million people reach any given milestone in a year, okay? And that means roughly 10,000 reach any given milestone on any given day. And that means that we can then actually reason about stuff like this, that number, 10,000 turning 50 every day, is actually pretty reasonable, okay? And from that, you can also see that this number that says that 88,500 reach 59.5, which is a magic number for retirement, in a week. It's about right. 7 times 10,000 is 88,500, right? Approximate numeric error. It's close enough. Or 350,000 turn, whatever it says, 50 every month. That's obviously the same thing. Or 4 million students graduate from high school every year. So you can see that these numbers are all consistent with that computation we did with Little's Law and just sort of how long do people live. Again, Little's Law is an approximation. It doesn't take into account that the birth rate, the death rate is lower than the birth rate. People are getting older on the average, that there's immigration, et cetera, et cetera. But it's a pretty plausible way to reason about things. Okay, still with me? Let me do a quick run through half a dozen things roughly that I think are interesting to watch for when you're thinking about numeric self-defense. Dimensionality, precision, trickery, etc. Okay, so let's look at it. How many people here from New Jersey? Good. Somebody up there counts twice? Good, thank you, sir. I mean, I have no axe to grind from New Jersey. I'm not from New Jersey originally, but that's okay. Anyway, one of the things that people who don't spend much time in New Jersey don't realize that it's actually the Wild West in some ways there, and that a major problem in New Jersey, even though it's one of the most densely populated parts of the country, is bears. And so every couple of years, the Fish and Game Council approves a bear hunt, where they go down through the center of every city in the state with big heavy-duty machine guns, and they gun down the bears. You're right, they will believe anything. Anyway, but what it means is that there are bear stories in the paper from time to time, and here's a nice one. This one says that young males roam 60 to 100 square miles looking for food and mates. I mean, this is absolutely typical of, undergraduate males, right? Except they're not looking for food, per se. And the females, be careful here, stay fairly close to the caves. They're more like homebodies in at least bear society. They stay within a 10-mile radius of the cave. Okay, they're looking after the kids. They're responsible. Anyway, so the question is, here we've got the male bears tracing off and having a great time, and the lady bears staying at home, or at least close to home, keeping an eye. What's the relative area that these two, the two genders cover? Well, you will remember elementary school arithmetic. What's the area of a circle? Pi r squared. Yes. So if r is 10, pi r squared, in this case, is well over 300. So the lady bears are actually covering an enormous amount more than the male bears. What's going on here? I have no idea. It's clearly nonsense. Whoever wrote it got the facts wrong in some sense. I conjecture, on the basis of not knowing anything about bears, that it should be that the lady bears are within 1 mile radius of the cave, which would make more sense if there's kids at home, right? No latchkey kids with bears, etc. So I'm guessing that's what it is, but I don't know, so who can tell? All right, next topic. That's an example of dimensionality, confusing a linear dimension with an area dimension, and sometimes you see it with a volume dimension. Next thing I want to talk about is oddly precise numbers. Let me give you one of my favorite examples of an oddly precise number. Does anybody here own a yacht that's 328 feet long? Could I make your acquaintance after class, sir? Because I don't have any friends. I move in a totally different circle than 328-foot yachts. But does this seem a little strangely precise, right? Somebody's saying, damn it, my last yacht was 327 feet, and it was really cozy, or you could get to know everybody. But this one's 329 feet, and you never see people. Can't possibly, what's going on here? So the answer is, the answer is, of course, that somebody asked this question or said something somewhere in, let's call it Europe. Says, these boats, once the boat gets past 100 meters, you lose the intimacy, right? Real wild round number, 100 meters, like we'd say 100 yards. And some reporter says, geez, I'm writing an article for people in the United States, and they don't understand metric. I don't even know what it is. I better convert it. Whip out the calculator and say, okay, 328 feet. And that becomes the story. And you'll see this number, 328, or multiples of it, all over the place. You'll see the inverse, 91.4 meters. That's somebody going the other direction, taking 100 yards into meters. You'll see it with weight. How many times have you seen that dogs have found a 22.4-pound cache of heroin? Right? Come on, that's 10 kilos. How much heroin was there, monsieur? I believe it was about 10 kilos. 22.4 pounds. It's captured in this cartoon from Rhymes with Orange. 28.35 grams, etc. You get the idea. Okay, so that's one kind of oddly precise numbers. And they're benign. It's just somebody not thinking about converting from one number system to another. Let's look at a different one. This is about identity theft. This is an article that showed up in the New York Times about 5-6 years, well, less than that, 4 years ago. And it observes that in a variety of ways, institutions manage accidentally to release information about people. Like, maybe somebody at Harvard releases a bunch of social security numbers that make you guys slightly more vulnerable to identity theft, or whatever. This can happen. And so there's an organization called the Privacy Rights Clearinghouse that tries to keep track of this sort of thing. And what they have there is they say, in 2 years, we've got 93,754,333 instances of this, or at least that's the rough figure. So if that's a rough figure, what's a precise figure? 0.000? The reason that this is like this is that this group, however worthy it is an advocacy group. The issue they are concerned about is release of private information, and it's in their interest to make the numbers as big as possible and to make them sound authoritative, and one of the ways you do that is to make them sound precise. And so that's what's going on here. If you go to their website today or last week, as I did, the number is now over 515 million. It has now 9 significant figures, and it's just, I think, as flaky as it was originally. Not that their issue isn't important, but you have to be skeptical of it when you see it. Okay, switching gears again a little bit. If I were a statistician, this might be more with a statistics cast. There's a wonderful book that, if you remember nothing else from this lecture, oh, and you should remember, there was something else you were supposed to remember, but I forgot. This book called How to Lie with Statistics, which was published in 1954 by Darrell Huff, still in print, still only about 10 or 11 bucks at various bookstores, really, really worth it. Huff had a lot of interesting things in that, including some examples of graphical trickery, and that's what I really want to talk about next. Some of those things are examples that were common even when Huff wrote it almost 60 years ago, and some of those things are new, enabled by computers. We can do things with computers now that would have been a lot of hard work in the 50s, and so the ante has gotten more complicated. Let me give you an example. One thing that Huff likes is the gee whiz graph. So here is something that shows that if your name begins with the letter C or the letter D, you're screwed, right? That your grades are going to be noticeably lower than people with other beginning letters, okay? That's what it should, I mean, there's the graph. How could it be wrong? Okay. And it's probably because there's some empathy for the letter C or the letter D that causes your grades to be lower. People whose names begin with C and D can self-identify. Okay, anyway, what's going on here? If you look very carefully over at the left side, you notice the scale? That the data, the meaningful is the wrong word, that the data really goes from a little over 3.34 to a little over 3.36. So in other words, it's an infinitesimal amount. And what's happened is that the base, the zero of this thing would be down somewhere, you know, about where the T goes underneath here or something like that. It'd be just way down under the ground. Because they cut off all of the stuff where there wasn't actual data. If you do it this way, what do you see? No difference. Of course, it's nonsensical. Now, you would say nobody would actually do this. This is probably a made-up example, et cetera, et cetera. Nobody would ever do it. Remember back in May, there was a bit of a flap in the stock market? And the stock market took a sudden, terrifying plunge one day for a few hours. Remember that? There it is. The upper one was the front page in the New York Times. Next day, that one was on Yahoo Finance or something like that. Boy, it's terrible. Values went to zero. Except if you look very carefully, you'll see that the scale is sort of from around 10,800 down to 9,900. So they've thrown away an enormous amount of the data. And if you plot it like it really was, it looks like that. Scary, but not quite the same, right? So this visual impact stuff is really, really important. And that's what Huff calls a gee whiz graph. Something to watch for. You will see that, especially in stock prices, an awful lot. Here's another one, something he calls a one-dimensional graph. Everybody, I mentioned Starbucks here earlier, everybody goes to Starbucks at least from time to time. Starbucks has been very successful as a business. It's had its little ups and downs, but it's been very successful. And this shows the growth in the number of Starbucks stores over a period from 1987 up to 2003 when the graph stops. And you can see that it's a slow start, and then it just blossomed. Amazing amount of Starbucks stores. I can find intersections that have Starbucks on diagonally opposite corners, right? So they really are everywhere. So this is believable, except, you notice the visual trickery going on here? The datum, the thing that's interesting, is the height of the curve. The height is the number of Starbucks there are that year. But what your eye sees is the volume of these honking big cylinders whose volume is proportional in some sense to the cube of the value. If you plot it the way it should be plotted, you get a different visual effect. Right? It's rising. It's obviously a successful business, but it's nothing like the impression that you see from this. Now, this is actually a fairly mild example. I have just a splendid example that comes from an institution which should know better, and it's not Harvard. This is the growth of some kind of money for grad students at Princeton from one year to the next. It really is funny. The height of the tiger is the datum. It goes from 500,000 to 2 million, right? So the tiger has grown in height by a factor of 4, and that's the data. But what they show you is the visual tiger, which is a volume object, and so factor of 4 cubed This tiger on the right is 64 times as big, and that gives you a completely fallacious impression of what's going on. So these are, unfortunately, all that common. A fine example of how to lie with statistics. Let me give you one more example of how to lie with statistics. You've probably seen this in one form or another. Every August, US News puts out an issue, very popular issue, that proves once again that Princeton is better than Harvard and or Yale. This has only happened, I've been at Princeton 11 years now. Exactly 2 of those years, Princeton has, in fact, not been first. It was second. One of those years, I think, was a technical error somewhere at US News. They just made a mistake. And the other is this year, when I'm here at Harvard. And so that's the reason why you guys are #1 this year. The problem with this stuff, and you see this all the time, is it's nonsense. What you do is you take flaky data, stuff like reputation score in the school or whatever, and then you combine it with arbitrary weights. And if you do that, you can produce pretty near any result that you really want. Just to pick an example, up in the upper right corner, it's hard to see, but one of the criteria is alumni giving rate. How loyal are the alumni? Now, Princeton wins big on this. 2/3 of Princeton alumni give money to the school. Harvard, by contrast, you cheap people, is down at 46%. So if the criterion was only alumni giving, Princeton would always win. There wouldn't be any competition, right? So it's completely arbitrary. They weighted at something like 5% this year. What if it was 7% the next year or 2%? Who knows? So completely meaningless. Okay. So I mentioned privacy rights. Clearinghouse is an example of an advocacy group. Let me give you an advocacy example here quickly. It's a question that you have to ask yourself all the time. Somebody gives you a number. Where are they coming from? What are they trying to convince you of? What's their axe? What are they grinding on their behalf, trying to convince you of something? So here's one. 4,000 teens will try their first cigarette today. Okay, this is a full-page advertisement on New York Times a few years ago. Is that a plausible number? Well, we have a way to reason about that now, don't we? Suppose that you're a teenager, you try your first cigarette on your 13th birthday. This is probably not even unreasonable, right? Okay. How many kids turn 13 every day? Well, we went through that, right? It's sort of 10, 11, 12,000. It's something like that. Maybe 1/3 of them try a cigarette. It's plausible. The adult population, what, 20, 25% smoke? It's plausible. So this is a plausible number. I could sort of believe it. This was actually an advertisement sponsored by a bunch of fairly heavyweight institutions like the American Academy of Pediatrics, the Heart Association, the Lung Association, the Medical Association, PTA, okay? Lots of people signed on to this one. Yeah, we like this. This is a good number. Okay? The next one is one where I genuinely, there's a 2-generation gap, and you will have to help me. Okay, show of hands. We will not take notes. But how many people think that this estimate of 5,000 kids trying pot today for the first time is right? Way too high? Way too high. Mostly, maybe not a majority, but a reasonable. Way too low? I didn't think so. Maybe about right? This is one where you just have it all over me, okay? Pot wasn't invented when I was in school, so I can't tell. But anyway. So I have no way of assessing whether this number is right or not, except that it's within the ballpark of the number of teenagers who, try pot. Maybe you do it on your 16th birthday instead of your 13th. I don't know, supply and demand, something like that. This was sponsored by the Coalition for a Drug-Free America. And that's an advocacy group, right? Their interest is in making their issue sound important and their numbers sound big. Not to say that it isn't a worthy thing, not to say that the number is wrong or something, but it means you apply a somewhat more skeptical eye to a number that comes from that than you would from the one above it. Okay. How about this one? Ladies? How many American women die, period, every year? We just went through that, right? 4 million Americans die, half of them will be women. That's 2 million American women die every year. Almost 10% of them die of anorexia. when the country is suffering just an epidemic of obesity? Not sure I believe it. Anorexia and bulimia are serious problems, especially for young women, but the number of young women who die of this is very, very small, extremely small. This number is, I don't know where it came from, if truth be told, but it's so weird that I actually went digging in the bowels of Princeton's Firestone library to find the book and find the reference, just to make sure I was not misquoting at least the author. Okay, and one last one. I don't even have to say anything about that one, because you know enough about how exponentials grow. This shows up, there's actually another book, I mentioned Huff's book. There's another book called Damned Lies and Statistics by Joel Best, and he cites that example as the worst social science statistic ever. Now, I'm just going to guess that it's a tough competition, but, you know, who could tell? Maybe that's... Did I hear some social scientists in the audience? Anyway, so completely nonsensical, and you could verify it very quickly by just saying, gee, what would happen by about 1980? There wouldn't be anybody left in the world. So, how do you defend yourself against all of this stuff? What do you do? All right, so you want to recognize the enemy, and it's everywhere. These are examples of the kinds of things that you will see. You want to be aware of who's telling you the number, because the source might be not totally disinterested in some way or other. On the flip side, it is helpful to know some things. It's helpful to be, you know, how big are things, how fast do they change, how do you convert from one system of units to another, and also some approximate arithmetic of the form that we've been talking about. And then finally, and probably most important, you want to use your own head. You know, use your common sense and experience. Decide, hey, does this make sense, or could it possibly be right? Or if it were right, what would that imply? Gee, I could run that backwards and discover that it's just not correct. So anyway, I mentioned Darrell Huff's book on how to lie with statistics. Joel Best he has an industry almost of cranking out these books. They're getting thinner, but they remain good. And there's a third one that I got just a couple days ago that I haven't finished yet. John Allen Paulus, who's at Temple, wrote a book called Innumeracy quite a while ago, which in some sense set the stage for a lot of this kind of thing. And then there's lots of websites. So anyway, what I would like you guys to do is to, you know, think about this stuff in your day-to-day life. If you see stuff, that would be great. If you see something that's good, send it to me. I would love to have it, because then I could have a new talk for some future visit to CS50. Anyway, thank you very much.